All right, graphing linear equations. We are going to move on to our next topic of linear equations, systems of equations. We're going to review graphing lines here because part of our systems of equations is to solve by graphing. We are going to talk about equations that are in slope-intercept form, and that is y equals mx plus b, where m represents the slope and b represents the y-intercept, which is your starting point. For the following, we're going to identify the y-intercept, the slope, and what it means for more points, and then we're going to graph it. When we are looking at our equation here, the number that does not have x with it will always be the y-intercept. And that means we're going to start on the y-axis. Let me zoom in here. So if we want to know our starting point, we're going to go down to, so we start here at 0, go down to -2, and draw the first dot. Then we're going to use the slope to get more points. Now, if it's a whole number, we're going to put a 1 underneath it. And then since it's positive, we're going to go up 3 to the right 1, and then draw another dot. So from the dot that we drew, we're going to go up 3 to the right 1, and then we can draw a dot. Up 3 to the right 1. And I just keep repeating this pattern, and I will go backwards as well. Because when we look at graphing systems, we're going to want to know where do they cross. So we want to have as much of a line as accurate as possible. Now, if I want to go backwards, I'm going to go back to my starting point. Instead of going up and to the right, I'm going to go down and to the left. So down 3, 1, 2, 3, to the right 1. 1, 2, 3, 1. And that's about what I've got room for. And then I connect these together. Okay, number 2. And you can pause this if I'm talk too fast, graph too fast, you can pause it and then come back. So here's our y-intercept. We can also think of this as an ordered pair. The ordered pair would be 0, 1. So I go up to 1 and draw my first dot. Then, since it's a whole number, well, negative number, I'm going to put a 1 underneath it. This time it's negative, so I'm going to go down 2, but still to the right 1. So from the dot that I drew, go down 2 to the right 1. Down 2 to the right 1. And you can keep repeating that pattern for as long as you want, and then go backwards. So go back to the beginning, go up 2, back 1, up 2, back 1. Number 3. So our y-intercept still looks the same. Again, we can think of that as an ordered pair. The ordered pair would be 0, 2, since we are going up to 2 on the y-axis. And then this time for our slope, we have a 1 on the top, so that means we go up 1 because it's positive. This time to the right 2. So from our dot, go up 1 to the right 2. And then we can go backwards as well. Down 1, back 2, down 1, back 2, down 1, back 2. All right, number 4. We have our y-intercept. And we can also think of it as an ordered pair. Go up to 3, draw your first dot. Now, with this one, there's not a number in front of x, but there's always a number in front of x. The number is always 1, and then we're going to put a 1 underneath that just to remind us that we have to move in 2 directions. We have to move up 1 and to the right 1 before we can draw another dot. Up 1 to the right 1 in every single corner on that line. Now, what about if we don't have anything that's been added or subtracted? Well, that means there's a 0, and we start at the center, 0, 0. And now we're going to go down 2 to the right 3. From here, down 2 to the right 3. Down 2 to the right 3. Okay, so we're always either going up and to the right or down and to the right until we go completely backwards. So up 2, 1, 2, 3, back 3. And we can connect those. Okay, number 6, again, 0, -1, or -1 is our starting point. This time we're going to go up 3 to the right 2 for more points. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 2, 3, back 2. 1, 2, 3, back 2. All right, we have a couple more remaining that are a little bit different. We've got y equals -x. So we don't have anything that's been added or subtracted, so we're going to put a 0. And then we're going to remember that this is going to be a -1 over 1 for my slope, our slope. So we're going to start at 0, 0. And then we're going to go down 1, right 1 to get more points. Down 1 to the right, down 1 to the right. So I see that just goes from corner to corner on all those, and then we can go backwards. So negative slope means that we go down when you're looking at the graph from left to right. Now, number 8 is written a little bit different. This is the number that's not attached to x. So that is still your y-intercept. Think of it as an ordered pair also, 0, -6. So go down to -6, draw your first dot. Then with the whole number for our slope, we're going to go up 4 to the right 1. 1, 2, 3, 4, 1. 1, 2, 3, 4, right 1. 2, 3, 4, right 1. And we could go backwards as well, just to give us a good line. And also it is good practice for when we get to systems again. Okay, now number 9. What's different about number 9 is there is no x in the problem. This is a horizontal line. So it's only going to touch at -8. And then we draw horizontal line going through -8. All of the y values on this line are -8. Okay, and then number 10, x equals, there's no y in this one. This is a vertical line. And this is the only time that we start on the x-axis. Only time. So we go to 5 on the x-axis and we draw a vertical line up and down. All of the x values on that line are 5. Okay, so we've drawn all of these lines. We've been talking about linear equations. So the different thing about linear equations, how many solutions does it have? It has infinitely many. Any number along the line is a solution. So for example, in this one, any point, we stop at any point on that line, it's going to be a solution to this. For our number 8, any point along that line, whether it's right on the dot that we have drawn or any of the dots in between, are going to be solutions. We've got infinitely many solutions when we're talking about a single linear equation.